The ancient city of Winchester, with its famous medieval cathedral, set in the heart of rural England, just 60 miles from London. Its traditional buildings and narrow streets serve as a reminder of its past. A city steeped in history, where Alfred the Great once ruled. In Anglo-Saxon times, Winchester was the capital of Wessex, and its historic city gate still remains. Winchester is perhaps an unlikely setting for the IBM UK Scientific Centre. To most people, art means painting, sculpture, or printmaking. Artists have always used the materials and technology available at the time. Art isn't usually associated with the computer, but we are going to look at the work of William Latham and how he uses the computer to produce art. Effects and images can be produced which cannot be created using any other method. And this is a new development in modern art. The computer is used as a creative tool to make sculptures in computer space. They exist in a strange world where there's no gravity and are not governed by physical laws. They look real, but you cannot touch them. They could be described as ghosts of sculptures, in the sense that they exist only in our imagination and as data. Where artists use paint and canvas, and sculptors use the chisel and marble, William Latham is using the computer keyboard and monitor as his artistic medium. To do this, he's had to convert his artistic ideas into a series of numbers which the computer can understand. The use of numbers makes the most complex geometry possible, allowing him to create perspective which gives the illusion of depth and space. The artist now describes how his early training in conventional art led him into using computer technology.
Like artists from the past, I originally used hand-drawn techniques to make art. I initially trained in fine art and produced paintings, sculptures and prints for a number of years before working with computers. It was here in the printmaking department of the Royal College of Art where I first became interested in the use of the mechanized reproduction of images through lithography and etching. I learned how to draw directly onto the etching plate, from which the technician would turn my drawing into a print. First, I drew on the plate using a sharp instrument. Then the plate was etched in acid for a short time. The plate is then inked up and wiped clean, leaving the ink embedded in the drawing etched into the plate by the acid. Using this elderly but thoroughly reliable piece of machinery, the plate is then fed into the etching press under very high pressure in contact with the paper. The paper is then peeled back from the plate, leaving an embossed and sharp image of my drawing. So here was my introduction to art being subjected to a mechanical process. And it was during this time at the Royal College of Art I started to create the evolutionary drawings, which eventually became my evolutionary tree of forms. As you look at this evolutionary tree, you find many different forms. You can see shapes like oriental plants, cacti, molecules, ceramics, crystals, and futuristic architecture. And this was the real genesis for me of a new form of art using the computer. The evolutionary tree of forms shows synthetic evolution. A number of simple operations are used in sequence. Beak, bulge, scoop, and stack. When used in sequence, they create forms of great complexity and variety. It shows how complex forms can be evolved from basic shapes.
For Latham, his evolutionary tree was something like a map of his imagination's catalogue of every possible sculpture. Some of his ideas were inspired by many forms of architecture. These Leonardo da Vinci drawings, found in his sketchbook, have a similar style of exploration of form and structure. When Latham worked on his evolutionary tree of forms, zoologist Richard Dawkins was producing these biomorph forms, and nature's evolutionary tree gave William Moore inspiration.
The idea for the evolutionary tree of forms came to me in the Natural History Museum in London.
The Natural History Museum is close to the Royal College of Art, and Latham often visited the museum to wander round and look at the many thousands of exhibits. He was also reading scientific journals, not to study the scientific text, but to absorb the myriad of shapes which science has to offer. He was intrigued by the shapes of the seashells, sea anemones, and starfish, and by the variation of structures within a species or family. He found great beauty in the simplicity of form in so much of nature, and was fascinated by the branching, segmentation, and spiralling of the forms. In the museum, he was able to browse through some of its 65 million specimens. Already he was thinking about how he could recreate some of the shapes and forms he was seeing. He was studying the classification of forms in nature from an artistic point of view. Antelope and ram's horns he looked at here were to suggest the twist, bend, branch and segmentation which would figure in most of his work. These visits to the Natural History Museum gave him a good look at the fruits of nature's evolutionary system. He imagined he could see a large tree of nature's forms, all connected to one another. And it was William's artistic interpretation of all these details which formed the basis of his computer work.
Animal horns, such as ram's horns and antlers, have always been a great source of inspiration and show the variation in form and structure in nature. After seeing so many forms, not only of horns like these, but of all the other exhibits and specimens, I had set about designing my own evolutionary tree of forms. But I had not foreseen the vast numbers and variety of forms I could create. In fact, the number is infinite. And this thought led me to consider using a computer to help me in my work. I realized that the sheer volume of work involved in creating thousands of drawings by hand would be beyond me. The computer's ability to cope with the repetitive drawing operations using iteration was absolutely necessary for this task. This meant I had to learn to program a computer. I decided to start with a basic horn form. I wasn't on my own when I decided to mechanize my drawings, as artists had tried centuries before. Another reason for using a computer was because I was attracted towards fractal designs, where a complex pattern is generated from a mathematical formulae.
William Latham now found himself working with the most advanced modern technology available. He changed his brush and canvas for the computer keyboard and monitor. He now had access to a unique solid modelling program called Winsome, allowing him to make imaginary forms in computer space using an IBM 3090 computer. And this led to a strange mixture of art and technology when he collaborated with scientist Peter Quarrenden.
Computers can only deal with numbers. For the computer, we have to reduce all of the shapes, the colours, the textures, to commands in terms of numbers. We're using here a program which was written at the IBM Scientific Centre called Winsome. To see how its commands work, let's take an analogy. Suppose we wanted to tell somebody to draw a circle on a piece of graph paper. You might say something like, open your compasses exactly 5 squares. Then count 6 squares across the paper and 4 squares up. Put the point of the compasses exactly there and draw a circle. To the computer, you have to type something very similar as a command. The computer knows what a circle is, and the numbers tell it how big to make it and where its centre should be. We do exactly the same to describe solid shapes, but here we're dealing with solid objects instead of drawings on a flat piece of paper. We have to give the radius of the sphere and tell the computer exactly where to put it in space. This position needs 3 measurements, not only along the screen and up the screen, but also the depth into it. The computer has drawn the sphere where we ask, but we can rotate it round to look at it from any view. If all we could draw was single spheres, the program wouldn't be very interesting. In fact, Winsome has a repertoire of 7 or 8 basic shapes, like cylinders, cubes, cones. We can also give it instructions as if it had a collection of imaginary machine tools. This method was originally developed for the computer-assisted design of small engineering parts. But here, we're not restricted to things which can actually be made. For instance, we can ask for shapes to be added together. This is called taking the union of the shapes. And because the objects aren't physical, it doesn't matter that they overlap. We can, instead of adding, subtract objects. In the computer's terms, this is called differencing. We can take the difference of the same cone and sphere. We can do this sort of thing as many times as we like, making more and more complicated shapes.
Stephen Todd explains how more complex forms are produced.
Building even quite a simple form by hand is laborious and repetitive. If you have to tell a computer where to position each object individually, that's repetitive as well. Luckily, computers were made to be programmed. So we can program a simple stack, change a number, and we get a bigger stack. We can have 100 high, 1,000 high, with no difficulty. Add an extra parameter. The computer can twist an entire form. Change the wording a little, and we can have a branching structure. This example shows an ellipsoid being stacked.
This shows stack and bend for coil forms. Stack, bend and twist gives contorted forms. This shows stack and grow. Here is the twist operation. One horn can have another horn growing out of it, and by using different combinations of horns, it's possible to create higher level functions, such as the horn web structure. Here we see the horn web rendered or filled in solid. By changing the parameters, William is able to create different horn-web forms, like these. The twist operation produces elegant forms of this type, inspired by ram's horns. This is a horn of horns. Each of these forms is defined by a sequence of operations and parameters. This is somewhat like a telephone number or a genetic code for a sculpture. By changing the telephone number, the form changes shape. By adding more numbers, the form mutates and so becomes more complex. This sequence of numbers or genetic code is translated into a wireframe drawing like a skeleton. This is then rendered by a technique called spatial subdivision, where the computer gradually sharpens the image and makes it solid. Texture and lighting are added to make it look like a photograph of a real object, which can then be made to rotate. The result is a film of an object which doesn't exist.
Finding out the shape of an object is only part of the problem. To make a realistic picture, we need to tell the computer how to light it as well.
Computer space is black without light. So the computer has to be given coordinates to control the source, direction and strength of the lighting. This adds to the realism, and the mood can be changed with different lighting.
More usually, the object is textured. The computer thinks of the object as being carved out of a block of the chosen material, say to give the appearance of shiny marble with randomly spaced dark veins. It then has to calculate from the position of each surface fragment whether it will fall in a vein or not. If it does, then it will be dark and rough, and if it does not, it will be light and shiny. The last stage is to take into account the variations of light and shade from the lights round about. This variation depends on a subtle combination of factors, not only the position of the lights and their colour, but the inherent colour of the material, its roughness, and even whether the material is metallic or non-metallic. The position of the highlights must be found. And for example, the more polished the surface, the sharper the highlights will be. All these effects have been studied over the years by scientists, and they have developed mathematical formulae to describe them.
Using a texture program, we can generate random patterns like marble, wood, or granite. Here we see the complete sculpture carved from different blocks of stone. The veins of the stone texture can be given different colours, can be shiny or matte, smooth, rough, or bumpy. These effects were used in Dutch still life painting. Latham has been inspired by stalagmites, the richness of Baroque architecture, the surrealist art of Matter and Magritte, and in particular with the science fiction film Alien, with its distinctive alien forms and imagery. And here are some examples of Latham's sculptures which developed out of these influences. They are the result of the marriage of the artist's imagination with computer technology.
Up to now, we've been looking at solid and static objects. Now I wanted to make them grow and change shape. To do this, we extracted the genetic codes for the sculptures and inserted these sequences of numbers into tables resembling an accountant's spreadsheet. And these were like a timetable for the metamorphosis of the form. To get natural and smooth movement, we used a technique called splining. This smoothly interpolates from the first set of parameters to the next. If we use this technique on several numbers, we can make parts of the form grow at different speeds, as seen in this green horn sprouting from this egg.
The results of this computer program can be surprisingly beautiful, like this synthetic flower form unfolding. Evolution was the next objective, To achieve this, the genetic sequence of the form is taken and randomly mutated by the computer to produce 9 close variations. First we see them rotating while changing form, and then the artist decides which form is going to survive to be developed further. Then the rest are killed off. Here are several families of forms produced using the evolutionary program. The artist now takes on the role of creative gardener, selecting some of his plant creations to nurture and develop, while rejecting others. A kind of natural selection operated by the artist. Perhaps this gives us an insight into the generation of form and structure in the natural world. By the process of evolution, we are exploring a multi-dimensional space of millions of sculptures of infinite variety and beyond our imagination. Just a small number of those millions feature in this William Latham film.